All right, guys, welcome back. We're going to wrap up our layer 2 discussion by talking about port aggregation, specifically layer 2 port aggregation. We certainly have the ability to do layer 3 aggregation as well with routed ports. And really the only difference between layer 2 and layer 3 aggregation is whether or not the ports that are involved in the aggregation are routed ports or switched ports, and whether they have layer 2 configurations on them, like trunks and VLANs and access ports, or whether they have layer 3 configurations like routing protocols, IP addresses, etc. So we have 4 different lessons in this particular section. Why do we need Etherchannel? What are the different modes of interaction, like LACP or PAGP or no protocol? How do we configure Etherchannel? And then how do we manipulate the load balancing options with Etherchannel? What are the load balancing options? Why would I choose one load balancing option over the other? What is the Boolean logic or Boolean math that's used to decide how load balancing occurs? Those are the things that we'll discuss in that section there. All right. So in our first section, why do we need Etherchannel? Well, we just talked about for quite some time spanning tree, right? And if links are not bonded together, spanning tree will consider that redundant connection a loop in the topology, and that link will be disabled. So we'll have the redundancy, but we don't have the additional bandwidth or throughput that link would provide if both links were active at the same time. So if I'm already going to have a secondary link attached between two devices, why don't I provide an opportunity to use the bandwidth for both of the links? And if one link fails, it's no different. It's kind of like there was a TV show where the dad or the son is the dad is coming to visit the son, and for Thanksgiving or something like that, and then the dad says, "Oh, the bags are in the car," and the son says, "Okay, I'll get the bags." And they're those old school luggage bags that or they don't have any wheels on them or anything, and he says, "Come on, Dad, how come you don't have any wheels on the bags?" And he says, "Well, what happens if the wheels break?" "Well, then you're back to where you started from in the first place, which is just carrying the bag." So it's the same kind of concept here. What happens if that secondary link that's bonded in the Etherchannel fails? Well, I'm just back to the same link that I had before if I didn't bond them together and spanning tree disabled one of those ports. So it makes sense to go ahead and bond those links together to give us not only the redundancy, but also the throughput. And that's what we call Etherchannel. Cisco uses the term Etherchannel to describe that. Other vendors might use link aggregation, port aggregation, and so on, but or link bonding or whatever. But the idea is that we're taking multiple interfaces and we're bonding them together so that they look like one logical interface. And spanning tree recognizes them as a single logical interface as well. In that spanning tree says, "Oh, okay, we've got additional bandwidth, so the path cost goes down. We can have both links active at the same time because they're bonded together into a single logical link." So we get that redundancy, plus we get the additional throughput. If one of the links fails physically or gets disconnected or whatever, we're just back to where we started from. So what are some of the characteristics of Etherchannel? We're aggregating links between the switches, gives us more bandwidth. We have load sharing capabilities. Now, granted, if you're using Cisco Express forwarding, particularly with a layer 3 Etherchannel, or you're using kind of an inferior load balancing method, we'll talk about that a little bit later on, you might get some polarization on a particular link, but and it's not going to be like per frame load balancing. It's going to be mostly based on flows, right? What's the source MAC? What's the destination MAC? What's the source destination MAC pair? Source destination IP pair, etc. Lots of different options to choose when we decide what our load balancing method is. Oftentimes, what we'll do is we'll implement Etherchannel, and then we'll go back in a couple of months and see, based on the interface statistics, which interfaces are being utilized the most, and we might decide to change our load balancing method based on the fact that one link might be used more than another. Okay. You can group up to from 2 to 8 physical ports in an ether channel. Some of the newer switches even let you go above that. But if you are doing ether channel, and I'll talk about this when we get into the load balancing section a little bit later on, you want to try and maintain load balancing numbers in binary pairs, right? So do two links or 4 links or 8 links, but don't do 3 links or 5 links and so on, because you'll definitely get polarization if you create an ether channel with, say, 3 links or 5 links, and it has to do with how the links are assigned indexes or indices to identify, and we use Boolean math to identify what frames or what flows go over what link. Like I said, we'll talk about that a little bit later on when we get into the section on the load balancing algorithms. Okay? Typically, it's going to be 2 ports or maybe 4 ports, but you can't mix port types, right? You can't put fast Ethernet ports into a link with gigabit Ethernet ports. They have to have the same speed, they have to have the same duplex, and logically, those ports have to have the same configuration. You would obviously not ever aggregate an access port with a trunk port, for example. It will let you do it. The configuration won't work, but definitely the speed and duplex needs to match on the interfaces themselves. All right. We can also configure multiple ether channels between 2 devices. So I can have more than 1 ether channel. However, so let's say I have 4 links between 2 devices and I decide to create 2 separate ether channels, each with 2 ports in each ether channel. One of those ether channel links would be disabled with the spanning tree, because again, that would be creating a loop in the topology. So there's really no need to do that. We would just simply bond all 4 ports together into a single ether channel so we could use the bandwidth from all 4 interfaces. But that is something you could technically do. All right. What are some of the other advantages of ether channel? Most of the configuration takes place on the port channel interface, which is a logical interface that gets created once you configure the ether channel. So if I've got 8 ports in an ether channel, I don't have to configure each of the 8 ports. I just configure the logical port channel interface, and that configuration gets propagated to the physical interfaces. We don't have to necessarily use faster links, more expensive interfaces, because we can create these virtually quick interface or links, if you will, by simply using more ports in the channel. Granted, it is going to take up those ports, but oftentimes that's a better choice than actually putting in a module with a 10 gig link or something like that. All right. We have lots and lots of different load balancing options, so we can make sure that we're not getting that polarization. Load balancing is not going to be perfect. It never will be. There's always going to be some sort of polarization taking place. But you want to get it as close to possible as equal cost load balancing. Based on how the algorithms work, though, you're never going to get it, perfectly load balanced. But you're definitely going to get better throughput. All right. Like we already said, spanning tree doesn't concern itself with multiple ports in an ether channel. It just simply looks at the ether channel as a single link. And then finally, that provides us the redundancy. So if an individual port within the ether channel fails, we might see some sort of topology change in spanning tree simply based on path costs change, right? The more ports that exist in an ether channel, the less that particular link costs in spanning tree's perspective. So if you do lose ports in an ether channel, there is the potential of the path cost changing based on the number of ports that are actually active in the ether channel. But overall, we shouldn't see too much of a change in the overall topology. Okay, so that's just kind of our introduction. Which 2 statements about ether channel technology are true? Ether channel provides increased bandwidth by bundling existing fast Ethernet or gig interfaces into a single ether channel. That would be true unless you interpret that as fast Ethernet and gig Ethernet together, but they do say or. Spanning tree can block one of the physical links in the ether channel. That would actually be negative because that's what we're actually avoiding. You can configure multiple ether channel links between two switches using up to a limit of 16 physical ports. Could be true, likely not. Most switches only up to 8 ports. Ether channel does not allow load sharing of traffic. That's absolutely false. Ether channel allows redundancy in the case of one or more links in the ether channel fail. Absolutely. So this option C could be potentially true, right? If you have kind of more of a modern switch that would actually allow you to have up to 16 links in an ether channel. But I would say pretty much that's not the case. Most switches are just going to be the eight links in the channel. All right. All right. So let's go into this. Sorry about that. Now, when it comes to ether channel, we have 3 choices in the configuration of an ether channel. We can use LACP, which is the Link Aggregation Control Protocol. That is an IEEE standard. We can use 802.3AD to be specific. We can use Cisco's proprietary ether channel protocol, Port Aggregation Protocol. Or we could choose to use no protocol and just do a static ether channel where we basically tell the switch just assume that the ether channel is functioning. All right? So what would be the choice, right? Is there one that works better than the other? And the answer is no. Ultimately, the end result is the same for all 3. The ports get bonded together. I haven't really found that any protocol is more efficient than the other. Certainly, if you're connecting to a non-Cisco switch, PAGP would not be one of the options that you could use. But I tend to stick with static ether channels myself. I just simply don't want to rely on some sort of negotiation for the ether channel to form. But if I am connecting to like a server or some sort of third-party device, I might choose to use LACP. But most cases, I'll just do a static persistent ether channel by just specifying the mode is on and not worry about any kind of protocol negotiating it. Now you'll notice that there are 2 modes in LACP and PAGP, active and passive, and desirable and auto. Much like DTP, where we had desirable and auto in DTP, desirable means that the port is actively trying to form an ether channel, and auto means that the port is passively waiting to be told to be part of an ether channel. So if I have 2 ports that are configured for auto on each side of the link, the ether channel will not form because nobody's actively trying to become part of the ether channel. Same thing with LACP. If I have 2 ports that are passive, the port will not become an ether channel, or the links will not bond together in an ether channel because nobody is actively trying to form the ether channel. Active to active, yes. Active to passive, yes. Passive to active, yes. Those ether channels will form. Same thing with desirable to auto, auto to desirable, and desirable to desirable. But if both sides are auto or both sides are passive, then the ether channel will not form. And by the way, these 2 protocols are not compatible with each other, right? LACP cannot talk to PAGP and PAGP cannot talk to LACP. What would you choose to do? If I was using LACP, I would probably do active on both ends. Again, not relying on one particular end or the other to form the ether channel. And if I was running PAGP, I would probably do desirable on both ends. So that we weren't relying on one particular end to negotiate the ether channel. By specifying the mode, you're actually specifying the protocol. You don't necessarily have, there is a protocol option where you can specify the protocol, but when you're configuring the ether channel, by simply specifying what mode you're going to use, you're actually specifying the protocol that's being used to form the ether channel. All right. Let's see. Is there anything here? Obviously, LACP being an IEEE standard, that's something that you could run in a mixed vendor environment. But again, the end result is still the same. You can have up to 16 links in the ether channel, but only 8 of them can be active at a time. Non-active links are placed into a standby state until another link within the ether channel goes down. So that's kind of specific to LACP in this case. All right, like I said, active means that we're essentially saying this port is an ether channel port, and it's going to send out LACP messages indicating that it wants to be an ether channel. Passive is only going to become part of an ether channel if it's told to be part of an ether channel in the negotiation process. All right. With PAGP, that's Cisco proprietary. Again, 2 different modes in this particular case. Desirable, where we're negotiating the ether channel actively. Probably shouldn't use that word, but you get what I'm saying. And then auto only will become part of an ether channel if it's told to be part of an ether channel. Okay. I haven't done a whole lot of research on this, other than the fact that one is open standard and one is proprietary, which is obvious. I don't really know that there's much of a difference between these 2 protocols. With regard to how long it takes for the ether channel to form, how many messages are required to go back and forth before the ether channel forms. I'm not sure that there are any significant differences in that regard. So I would say, if you're going to use a negotiation protocol, just kind of stick with the IEEE standard, and you should be good to go. Now, you could do static mode, right? Static mode is when you're not using a protocol at all, and basically the ether channel is going to be configured manually. There's no negotiation that happens between the 2 switches. There's no checking to verify whether or not the other switch can participate in the ether channel. It just simply assumes that the other side is configured, and the ether channel will come up and start running. So this does, of course, require that you have that you as an administrator verifies the configurations on both sides of the ether channel, because obviously it's not going to communicate if it's misconfigured, but you're also not going to get any indication that it's misconfigured because you're not running any dynamic protocol to identify that misconfiguration. Does that make sense? So I like this mode because it just simply doesn't, we don't have to wait for any negotiation to take place. And generally speaking, the ether channels just usually work as long as they're configured correctly. All right. The static mode means that the protocol is set to on. It's very simple. You go into the interface, you say channel group, channel-group, give it a group number, and you say mode active, mode passive, mode desirable, mode auto, or mode on. And by specifying the mode, you're specifying the protocol. All right. Which statement is true about ether channel mode interactions? LACP is a Cisco proprietary protocol. Negative. It is an IEEE. If you configure one of the link as passive and the other as auto, the ether channel will work. Negative, because for 2 reasons. Number 1, both of those don't do anything to negotiate the ether channel. Number 2, those are completely different protocols and they're not compatible with each other. You can commonly place 64 links into an ether channel bundle. Nope, we know that the limit is 16. LACP has mechanisms to check the configuration consistency between bundled ports. That is true. So does PAGP, by the way. Because we're doing the negotiation, we can identify inconsistencies in the configuration. All right? So that would be the appropriate answer in this particular case. So what are some of the configuration guidelines? For the most part, the configuration has to be consistent. All the interfaces that are part of the ether channel have to have the same configuration. They have to be in the same mode. In other words, layer 3 or layer 2. If you have configurations on the interfaces, those configurations have to be consistent. with regard to, is it a trunk? Is it an access port? Is it pruning VLANs? Is it not pruning VLANs? Is it an access port in a particular VLAN, and so on? You want to make sure that all those configurations are either cleared off the interface or they match. Of course, you also have to make sure that you have the same speed and duplex, the same interface types, and so on. So in order to set up an Ether channel, the first thing you need to do is you need to identify which ports are going to be part of the Ether channel. Then you create what we call a channel group number. That channel group number is completely arbitrary, and it is locally significant to the switch. The channel group number does not have to match on both ends of the link. Typically we would make it match, but it doesn't have to match. It's only locally significant to the switch. So you could have port channel 3 talking to port channel 2 on the other side. All right. And then you specify the mode which sets the protocol. On, no protocol, auto or desirable, PADG-P, and active or passive LAC-P. And then finally, if you haven't already configured the physical interfaces with their logical configuration, you go into the port channel interface and you configure the port channel interface with the configuration. Now, what is the port channel interface? Well, the port channel interface is a virtual interface that gets created based on the channel group number that you chose for the Ether channel. So if I go into a set of interfaces and I say channel group 1 mode on, as soon as I hit return, port channel interface 1 is going to get created, which is just a logical interface that ties the configuration of all the physical ports into a common Ether channel configuration. So that's ultimately what the goal is with the port channel interface. It gives you a way of configuring all of the ports consistently together as part of that particular Ether channel. All right, so again, the first step, identify what ports you want, specify the protocol, make sure the ports have the same speed and duplex, and then verify. And we use really one command to verify the Ether channel, and that's show Ether channel summary. All right, you guys are going to be doing this in a minute when you go into the exercise. Make sure the port channel interface configurations are consistent and correct, because usually whatever you configure on the port channel gets duplicated to the physical Ether channel, which can affect how it operates. The physical interface configuration changes affect only the interface. So if I go into an interface and I say speed 1000 or duplex half or whatever, that configuration, which is applied at the interface level, only applies to that interface. And most likely that would then result in that interface being removed from the Ether channel because it's not consistent with the other interfaces within the group. All interfaces within the Ether channel must have the same speed, duplex. They must be either access or trunk. They have to have the same trunk configurations. I mean, we're talking all the way down to like descriptions. The interface configuration needs to be the same. Typically that's done by just simply configuring the logical elements of the interface on the port channel interface so that it gets duplicated to the physical ports themselves. All right. Ether channel support. All Ethernet interfaces on all modules support Ether channel with no requirement that the interface be physically contiguous or on the same module, meaning that you can actually, if you had a switch stack, for example, like a 3850 switch stack with a stackwise ring on the back, you could take a port in, as long as it's the same speed and duplex, you could take a port on switch 3 in the stack and bundle it with a port on switch 5 in the stack. It doesn't really matter in that case. We can also do Ether channel over what we call VPC links as well, like the Nexus products. Speed and duplex needs to match. The VLANs have to match. The range of VLANs that are allowed across the trunks have to match. The spanning tree path cost. Interfaces with different spanning tree port path costs can form an Ether channel as long as they are otherwise compatibly configured. In other words, changing the path cost of an individual link within the Etherchannel bundle does not break the Etherchannel. It will affect the overall spanning tree path cost because, again, spanning tree considers all of the links in the configuration when it calculates the overall cost of that Etherchannel link. All right. And then lastly, do I do a port channel configuration or do I do a physical interface configuration? If it's logical stuff, like what VLAN does the port belong to, or what is it a trunk, what VLANs are allowed across the trunk, what trunking encapsulation method am I using? If it's all the logical stuff, that would get applied to the port channel and it would automatically get duplicated to the physical ports in the Etherchannel. There are some configurations that you have to do on the physical ports themselves, though. Speed and duplex would be one of those things. All right? But 99% of the time, you're going to be applying your configuration by utilizing manipulating the port channel configuration, not the physical link configurations. Okay? What is not a requirement for Etherchannel configurations? Interfaces must be the same speed and duplex. Interfaces must be physically contiguous. Interfaces must have the same VLAN configuration, or interfaces must be in the same mode. So B would be the choice here, right? They don't have to be contiguous. They just have to have the same speed and duplex, the same mode, and they have to have the same VLAN configuration, whether it's a trunk configuration or an access port configuration. Okay? There are some other restrictions with things like span and port security and so on with Etherchannels, but when we get into those topics, we'll talk about what those limitations are later on with regard to an Etherchannel. When it comes to Etherchannel load balancing, there's always going to be a default load balancing mechanism that's going to be implemented, and it is somewhat platform specific as to which load balancing method is going to be turned on by default. But we do have several different load balancing options available to us. I can create a hash input code based on destination IP, destination MAC, source destination IP pairs, source destination MAC pairs, source IP, and so on. Now, what does this mean, a hash code? Well, essentially, when we're doing an Etherchannel load balancing choice, or when we're deciding how we're going to load balance, we create, I'm going to kind of break it down basic in a basic format, but we create essentially an interface index number for a particular port. So let me kind of break it down into a really simple way to understand how the hashing method works, and it does, again, vary by platform, but this will give you at least a general idea. Let's say I have two interfaces in an Etherchannel. All right, and I decide that I'm going to bond those two interfaces together. Let me change the font size here. Each of those interfaces, so interface 1 is going to get an index number. We'll just say that index is 0. And interface 2 is going to get an index number of 1. All right? So how many bits do I actually need to uniquely identify each interface in the group? 1, right? Either a 0 or a 1. So let's say I'm doing a combination of source and destination IP load balancing. Let's say that the packet is coming from 10.10.10.1 and it's going to 172.16. We'll just do 10.10.11.56. It's too late in the day for that. Let's do 36. Okay? So that's the source and destination pair that they're referring to. What's the source IP address? What's the destination IP address? And we use Boolean math to identify the interface index. And now I am wondering if it's an AND or an OR. It's an XOR operation. Okay. For some reason I forgot that, but we're doing an XOR operation. I'm basically describing what the book is describing, and I'll show you in the book as well. But we're going to do an XOR operation to identify which interface index this particular packet flow gets assigned to. So we don't really care about the first 3 octets because we only need to use the last bit to identify the interface index. So the last octet in the source IP is 12341234, and the last octet in the destination IP is 1231234. Sorry, 78. Right. All right. That's 36. 32 plus 4 is 36. So if I take this last bit, and that's where I apply the XOR operation, the result of that XOR operation is going to basically tell me which index that flow goes over. So let's say a 0 and a 0 is equal to a 0. A 0 and a 1 is equal to a 1. A 1 and a 0 is equal to a 1, and a 1 and a 1 is equal to a 0. Remember, an OR operation, XOR operation is if one or the other value is different, then the output is a 1, and if they're the same, the output is a 0. So based on this, this particular flow would go over this interface. All right? Now, if I had another packet, maybe it was 10.10.10.1 talking to 10.10.10.38. Guess what? It would go over the same interface. In fact, all of the even number, well, not necessarily. It depends on the source and the destination. But you could see how you could get some sort of polarization if this particular flow is very active, right? And this particular flow, let's do 37, is not as active, right? You could definitely get some polarization in that case because, you know, maybe we're sending a lot more data using the first flow as opposed to the second flow. The second flow is going to go over interface index number 1, and the first flow is going to go over interface index 2. So one of the things they say in the book, and one of the things I always describe to my students, is the more flows that you have, the less likely you're going to see polarization, or you're going to get kind of more towards that normalization of load balancing because you just have more flows to choose from. But what happens if I add 3 interfaces into an ether channel? Right? I decide to add 3 interfaces into an ether channel. Now I need 3 different index numbers. Well, I can't use a single bit to represent the index. I have to use 2 bits to represent the index. So this might be a 0, 0. This might be a 0, 1. This might be a 1, 0. But what happens to the 1, 1? Because we could have an XOR operation that results in 1, 1, which means it has to go somewhere. What's going to end up happening is that index will get assigned, or that XOR operation or output will get assigned to another interface. And this is why I said when you're doing ether channel load balancing that you want to ensure that you have, you know, kind of a binary exponent or binary factor of interfaces or number of interfaces in the ether channel. Because when you have an odd number of interfaces, say even 6 interfaces would result in the same problem. If it's not a power of 2, you're going to get polarization because certain interfaces are going to get more index numbers assigned to them. All right. Now, how do I allocate traffic to these indices? Allocating traffic to these indices would be the same. The only difference is I'm doing an XOR operation on the last 2 bits of the packet information as opposed to just the last bit. All right. It's a lot more complicated than this, obviously. There's a lot more going on in this process when we're identifying load balancing, but this is how just about every book describes it because they want to make it seem relatively simple. Fundamentally, this is how it works, right? So if I'm just doing destination IP address, there is no XOR operation in this case, right? Destination IP, there's nothing to kind of XOR together. So we just simply use the last 2 bits of the address, or we use the last bit of the address, and that will determine what index number it goes over. Destination MAC, same thing. We distribute across the ether channels based on, sorry about that, my session timed out there. But anyway, you can kind of now get the idea of what these different load balancing mechanisms represent. Source and destination IP, source and destination MAC, source IP, source MAC, destination IP, destination MAC. Now, what load balancing method you decide to use will really depend on the types of traffic flow that you have in your network. And that's why I said usually when you set up an ether channel, you'll eventually get to the point where you want to kind of verify and troubleshoot ether channel, and you're going to use various show commands like show ether channel summary, or maybe you might even look at the interface statistics to see if the load balancing algorithm that you chose is adequate for the traffic flows that you have in your topology. Does that make sense? So it might require a little bit of tuning and kind of some setup and configuration in that regard. What we're seeing here is 2 ports in an ether channel. So this was the first one that I described where we were only using the last bit to identify the interface index that we were going to use to send the traffic, right? And this was based on a source and destination IP load balancing method. 1.2, 1.4, both of those are even numbers, so they're going to result in an XOR output of 0, which means index 0. 21 and 20 are 0 and 1, so that's going to result in an XOR of 1, and so on. Like I said, if you have more links in the bundle, you're going to need maybe 2 bits. If it's 4 links in the bundle, you're going to need 3 bits, and so on. It just depends on how many links you have in the bundle. You want to make sure it's a nice even pair, right, for optimal load balancing, so you don't get that polarization. You want this 1-to-1 to 1-to-1 ratio. Everybody understand what they mean by a 2-to-1 to 1 ratio. That means that we have 3 links in an ether channel, and in this case, 1 link is going to be assigned 2 index values, because we have we have to use powers of 2 math, which is 4 possible index numbers, and we can't just ignore one of those index numbers, if that makes sense. All right. All right. So frames are forwarded over an ether channel link that is based on the result of the hashing algorithm. Which of the following 2 options can a switch use to calculate this hash? We know destination IP address is one of them. Port numbers could be used as well. We wouldn't use VLANs. Anything that has to do with the actual PDU, right? The packet flow. We don't really identify a VLAN within the packet flow. We don't identify a router ID within the packet flow or a loopback address. It could be an IP address, maybe the loopback is the source or destination IP. But in this case, they're referencing the fact that we would be using a physical interface as opposed to the actual IP address on the interface, if that makes sense. So think about the types of stuff that you would see within a packet flow, and those are the options that you have with regard to load sharing, right? And identifying the load sharing mechanism that you're going to use. Again, you're going to have to go through the process of kind of evaluating which one's best in your environment. Honestly, for me, it is something I don't typically change. Unless I see some serious polarization on the interfaces, most of the default load balancing methods are pretty adequate, and you don't have to worry about it too much. All right?
Yeah, that was going to be my question. When would you actually go off and change from the default? So I don't think I've ever actually went in and set this in a real world setting.
So the way that you would kind of investigate whether or not your load balancing method is inefficient, the easiest way would be to clear your interface counters for all the interfaces that are part of the ether channel. Let the ether channel run for a day or 2 days or 3 days, and then go and do a show interface on the interfaces in the bundle and look at the output, the byte count and the packet count, and see if you're seeing a lot of polarization on the ether channel link. If you're seeing, say, 5 times or 10 times more traffic over a single link, that means that you probably have maybe a host or a pair of hosts that are talking a lot more than other hosts. And maybe in that case, you would want to use some sort of different load balancing mechanism, like specifying just the destination or just the source or whatever. As far as which algorithm to choose, that's a little bit more challenging, right? Because you have to decide what your flows look like, and you're going to choose an algorithm based on the characteristics of the flows themselves. Does that make sense? So that would require, you know, a little bit more investigation on your part. Maybe you modify the settings slightly, go back and check it again after a while. But for the most part, you know, it's not something you typically have to change, because usually ether channel links are going to be configured over high traffic connections, over, you know, where we're sending a lot of data, and the more data flows you have, the less likely you're going to get polarization, just because you just simply have so many flows to choose from. You're going to get kind of an adequate level of load balancing in that particular case. Does that make sense?
Yep.
All right. So the last lecture component of this, before we review the lab, is how do we troubleshoot ether channel issues? Well, it depends, right? We just talked about the load balancing mechanism. Maybe I'm seeing a lot of polarization, so the troubleshooting techniques that we use there are completely different than if the ether channel doesn't form. But I will tell you, the most common issue with an ether channel not forming is that you just simply don't have mirrored configurations or similar configurations between the ports that are participating in the ether channel. So you're going to have to, of course, go and verify that configuration. There are other reasons why an ether channel might fail. I've seen it a lot where the ether channel, you're configuring one side of the ether channel and you haven't yet configured the other side, so there's kind of a half configuration, and so the switches or the routers kind of freak out a little bit. Maybe ports error disable, or they stop functioning because they think there's a misconfiguration. So my recommendation when you're setting up an ether channel for the first time is to shut down all the ports that are part of the ether channel, including the port channel interface. Make sure you have all your configurations applied, and then bring up all those interfaces using the range command so all the interfaces come up at once. You know, what are some of the other common issues? Well, you could have a scenario, for example, where you're running the wrong speed in duplex. You can have a scenario where you're running the wrong ether channel mode, right? You've accidentally configured mode passive or mode auto on both sides, or maybe you did auto on one side and you did active on the other side by accident. So you've got PADG-P on one end and LAC-P on the other side. There's all kinds of reasons, obviously, but it's most likely going to be a configuration related issue. It's not really going to be, I mean, ether channels are pretty basic. When they are configured correctly, they tend to work. There are some other limitations, right, with regard to port security, with span, and with other features you might run in the network, and some limitations and restrictions on what you can apply to an ether channel based on that. But let's talk a little bit about the output, right? The most common output, which is one you would run in the lab, of course, is show ether channel summary. That is the primary command that allows us to verify the operation of the ether channel. Is it a layer 2 ether channel? Is it a layer 3 ether channel? Are the interfaces participating in the ether channel? Are the interfaces out? Do they fall out of the ether channel because they have a misconfiguration? Those kinds of things. Okay. And those are things that we would verify, and then we of course go through our standard troubleshooting techniques to identify the issue. So it's not a whole lot you can do for troubleshooting. It's a pretty straightforward, you know, thing to troubleshoot the ether channel. It's make sure that you're running the right mode, make sure there aren't any inconsistencies with the configuration, and again, we see show ether channel summary or show ether channel group detail. Those are pretty much the two commands that we use to verify our ether channel. All right. So what would I see? Let me see if we have any designations here. Right. So an S would indicate that the port is suspended in the ether channel. P would indicate that the port is passive in the ether channel. Meaning that it's bundled in the ether channel. It doesn't mean that you're running passive mode. I always say P just means you're participating in the ether channel as opposed to passive in the ether channel. So there are some indications, and when you look at the show ether channel summary output, which we'll see in the lab next, you can see what those keywords are, those shortcuts are. Active should work, active passive should work, desirable should work, desirable auto should work, and on should work. D would indicate that the ether channel is down. You might see that from time to time if there's a protocol mismatch, or you know, maybe you're running a different encapsulation, or there's some sort of issue with what's running on the interface. The port might move to independent mode, where it's basically operating as an independent port. And D, of course, means that the port is down. So there's several different options that we have to troubleshoot the ether channel. Unequal distribution, what we call polarization. We talked about that. Show ether channel load balance allows us to identify what load balancing method we're going to use. However, I have not found, outside of looking at the counters on the interface, there isn't a specific command within Etherchannel to identify how much a link is being utilized within the Etherchannel. Does that make sense? So that would be nice if we had kind of a basic command that just said, hey, show me what my utilization looks like on each of the links in the Etherchannel. You kind of have to use the counters, interface counters, and interface statistics to see that information. Okay? But we know why polarization could occur based on the algorithm that's used to load balance across the ether channel. You could use show ether channel traffic. That'll give you some information about you know, how much traffic is being put over a single link, but it's not necessarily going to give you the details. You know, who's generating that traffic and why are those pairs what they are, right? So you have to do some additional investigation to see that information. The last thing we talk about is Etherchannel Guard, which is a spanning tree toolkit option to allow us to prevent inadvertent loops in our topology because of some sort of misconfiguration in Etherchannel. And this is disabled by default, but it's pretty easy to enable. You would just enable it globally on the switch. And if for some reason there's an issue with the ether channel, which would potentially cause unidirectional data flow, then if I have unidirectional data flow, there's a potential that I'm sending BPDUs, but I'm not receiving BPDUs, which means I might assume that a link is not a loop, and I might activate it, which would then cause a loop. So we use Etherchannel Guard to basically bring down the ether channel if it's not operating correctly or not functioning correctly. All right. By default, that's not enabled, but that's just a global command, spanning tree Etherchannel Guard enable, that we use to enable that feature on the switch. All right. The table is an overview of Etherchannel establishment modes between 1 and 2. The physical link parameters and trunking modes are the same on all of the interfaces. Which two of the links will participate in aggregating the channel between the switches? So obviously port 1 would work. It's active. Port 2 would not work. it's active on. And mode on does not allow any negotiation of ether channel. Active auto would not work because those are two different modes of ether channel or two different protocols, and port 4 would work because it's passive and active. Makes sense, right? So in this case, Ethernet 01 and Ethernet 03, 04 would form an ether channel. However, I've never done this before. I assume it would work, but it's kind of a strange configuration, right? You wouldn't make one port active on one side and the other port passive and kind of mirror that configuration. All the ports on one side of the link would be active, and all the ports on the other side of the link would either be passive or active to form the ether channel. But I think this would work. Ports 1 and port 4 would join the ether channel. The remaining ports would not. All right. So let's take a look at the lab exercise, the discovery that you guys did. In this lab, we basically have two switches. We're setting up an ether channel to join two different interfaces together in port channel 1 and port channel 2, which means that spanning tree is going to disable one of those port channel interfaces because it would cause a loop, assuming they're running the same VLANs. Let's see, interfaces 00 and 01 are port channel 1, 2 and 3 are port channel 2. PC1 and PC2 are in VLAN 11. We have a .1Q trunk enabled on all of the interfaces, and the switches are intended to operate with devices of other vendors. So that means that we're going to be using either a static ether channel or we're going to be using LACP in this particular case. All right. All right, this would be similar to what you might see on an exam question. You know, obviously there's no simulations on this ENCOR test, but you might see something like where you have to actually configure an ether channel. On the old switch test, you had that, right? You had to set up an ether channel, and they told you to use an open standard protocol and identified which ports were going to be, or which switch was going to be negotiating the ether channel and so on. For some reason, there's an issue with the configuration. Port channel 2 on switch 2 is in the down state. On switch 1, Ethernet 00 is not part of the ether channel. All right. So if we do a show ether channel summary, that confirms the current state of the ether channel. We have two groups, port channel 1 and port channel 2. SU means that the port channel is layer 2 and it's operational, it's in use. But we can see that one of the ports in the ether channel is suspended, the other port is bundled or participating in the ether channel. And on group 2, it's down altogether. Both ports are suspended. So my first inclination would be just go ahead and take a look at the configuration of the ports and see what the discrepancy is with the configuration of the ports. But what they did is they went into the other switch and did a show ether channel summary on the other switch as well. And they see very easily, very quickly, that one of the ports is just simply not included in the ether channel, which makes sense, which explains why the other port would be suspended from the ether channel, because the corresponding port on the other side is not even bundled in the ether channel. I can also see for group 2, there's a dash for the protocol. And a dash for the protocol indicates that we're not running a protocol, which means that we're running mode on. All right, well that could be an issue as well. I mean, it will be an issue. We can't run active and mode on or LACP and mode on and have it form the ether channel. So now I would go investigate my running config. We can see for switch 1 for fast Ethernet or Ethernet 02, the channel group is set to 2, but the mode is on. For port 3, the mode is on, so we simply have to change the mode. You cannot simply overwrite the mode. You actually have to remove the mode and then reapply the mode to the desired mode that you're trying to configure. You can't just simply remove the mode and then or remove the mode or change the mode by overwriting the command. It'll just say you can't change it because it's already set. So we do remove the mode, and then we reapply the appropriate mode, and we might have to reset the ports as well. It should come up. Sometimes it doesn't. So you might have to reset the ports to bring them up. All right. So we went no channel group 2 mode on. That brings down the port channel interface because we removed the channel group number, and channel group 2 mode active. And of course that enables LACP on the ports, and then it says, oh, wait a minute, LACP is not presently configured on the remote port. All right, so if I do a show Etherchannel summary, I see now we're running LACP, but the ports are suspended. Now, if I look at group 2 on the other switch, I can see that we do have port channel 2 configured, but it looks as though there might be some inconsistencies with the port configurations. The port channel on the left has pruning on the VLANs. The port channel on the right does not. In that case, the ether channel will not form. They have to be a mirror configuration of each other, even down to the point where you actually specify a description on the port channel. The only thing that doesn't have to match is the port channel interface. All right. So, for example, I can use like 2 on the left side and 3 on the right side. That's kind of, I mean, it's a locally significant value, so it doesn't really matter. Kind of makes sense to make a match, though. So it says here, for the ether channel to be enabled, the following must match: the mode, the VLAN number, the native VLAN, allowed VLANs. Basically, all of the configuration has to match. So we go ahead and apply that configuration. We do a show ether channel summary. It takes probably a couple of minutes. The ether channel comes up. It might not actually come up automatically. You may actually have to go in and manually shut down the ports and bring them back up for the ether channel to come up. Okay? All right. I mean, you can see why it's a pretty basic. You're not going to run into any kind of crazy configuration issues with ether channel. If you follow the basic guidelines, make sure you have compatible protocols and make sure the interfaces have similar configurations, you shouldn't have a problem at all getting the ether channel to function correctly. It should work just fine. All right. Step 6, show ether channel summary. We can see that ether channel, the group number for switch 1 is missing a port. And if I go into the actual configuration of the switch, it is configured as a layer 3 interface, not a layer 2 interface. So you can't mix and match layer 3 and layer 2 as well. You can create an ether channel over layer 3 if all the interfaces participating in the ether channel are layer 3. But you can't mix layer 3 port configurations with layer 2 port configurations. Makes sense why you wouldn't be able to do that. So what's the fix? The fix, again, is to just make sure that your ether channel configuration is consistent. Okay? All right. So we type switch port that converts the port back to a layer 2 interface. Switch port trunk encapsulation.1q, switch port mode trunk. Notice there, in this case, they're applying the logical configuration to the physical interface. There's actually nothing wrong with doing that. In fact, when I'm configuring ether channels in the real world, I actually will apply the logical configuration to the physical interface as well. Because what I want to happen is if for some reason the ether channel fails and the port becomes an independent port, I want it to maintain its status as a trunk port. I don't want it to get its status or glean its status from the port channel configuration, because if the port channel goes down, then the port loses its status, and it might actually no longer be a trunk port. It might end up becoming an access port in VLAN 1 or something like that. Something to consider. I generally will configure the port channel interface and then configure the physical interfaces all together in a range. so they all have the same configuration. You can't do that with layer 3 ether channels. Layer 3 ether channel, you can only configure IP address information on the port channel interface. You can't do it on the physical interface. All right, show ether channel summary again, verifies that the ether channel is up and running as it should be. All right, any questions about that exercise? Let's go through our review questions and then we'll wrap up this lesson. So what is the correct command for configuring load balancing on an ether channel link? Channel group number load balance method in global mode, channel group number load balance method in interface mode, port channel number load balance method in interface mode, or port channel load balance method. It's going to be the last option here. We would never do any kind of load balancing configuration in the interface specifically. But here's another good point about this. I have multiple ether channels on my switch. I cannot change the load balancing method per ether channel or port channel group. I can only choose one load balancing method on the switch, so that's going to apply to all of my ether channels. That might be a challenge later on as well, because you might have different interfaces or different ether channels that are seeing different types of traffic flows and traffic patterns, right? So unfortunately, you kind of have to pick the best of all your worlds and pick one that's going to work the best with, on average. Which of the following ether channel modes does not send or receive any negotiation frames? That would be a static ether channel. On. Which two of the following options correctly defines the characteristics for ether channel? Okay, it'll give us more bandwidth. Load sharing. Yep, absolutely. Multiple logical ports for rapid spanning tree. Nope. The ether channel looks like one individual port. Server scalability. No. We can certainly provide more bandwidth to a server by doing link aggregation and configuring ether channel to the server, but that doesn't mean we're increasing the storage capacity or the processing capacity of that server. And low convergence timing, I'm not sure exactly what they mean about that, but convergence is going to be a factor of the other protocols like spanning tree or routing protocols, how they're set up if you're running BFD or OSPF LFA or something like that. That's when you would increase the speed up the convergence time. Please place the steps to configure ether channel in the correct order. All right, so we're going to identify which ports to use. That's going to be step 1. Guess they already did it for us. Configure the channel group on the interface, and then set up the port channel interface. Remember, when we add the channel group to the interface, the port channel interface is going to be automatically created, and then verify with the show ether channel summary or whatnot. Which of the following two commands can be used to check the status of a member interface? Show ether channel summary and show ether channel group number detail. Those are going to be the two commands. We can use show ether channel load balance, but that doesn't really give me any information about the specific interfaces participating in an ether channel group. Which of these is not a load balancing option? Obviously destination name. I don't even know what that would reference unless they're referencing DNS in this particular case. Certainly IP, MAC address, port, the stuff that you would see in the packet and transport layer headers and the frame header, right? Literally the stuff you could pull from those headers. DNS name is not anything that's included in any of the OSI model headers. Which two protocol choices do you have when you are implementing an ether channel bundle? Well, LAPD, I like that one. PAGP and LACP. LAPD and PAGP are protocols, but they're related to legacy stuff. What is the correct command for configuring load balancing on an ether channel? It's going to be
Back to the duplicates.
Back to the duplicates. Yes, thank you. All right. So that wraps up that lesson. Let's see where we're at, and we'll figure out what we're going to do for the rest of today.